Alright, a video on the law of cosines. The law of cosines is one of those laws that we will use to find missing pieces of triangles that are not right triangles. Alright, we call those triangles, if a triangle is not a right triangle, we call it oblique. That means it's acute or obtuse. So this is one of the laws, along with the law of sines, which we'll talk about in the next video, that really comes in handy. This law comes in handy when a triangle is not a right triangle. Alright, so we can't use like regular, we can't use regular sine, cosine, and tangent for some triangles, right? In these triangles, these don't really apply. So we have to use these special laws. And here is the law of cosines in all three of its iterations, right? If we start with a lowercase a, that is a side length. The convention is lowercase letters are sides, capital letters are angles. So if it starts with a lowercase a, it has to end with a capital A. And then B and C are here. Kind of looks like the Pythagorean theorem. Minus 2 times BC, BC, BC. These are all multiplication symbols here. So if it starts with a lowercase b, it has to end with a capital B. Starts with a lowercase c, ends with a capital C. So we're going to use, for each problem, sometimes use different versions of the law of cosines, but they're all really the same, just kind of shuffled around a little bit. So let's go to talk about when we use the law of cosines. So you'll use the law of cosines when you have situations where you're given a side, and an angle in between. So it's side, angle, side. Or when you're given three sides. Side, side, and side. Again, these triangles are not right triangles. None of these angles are right angles. So we can't really use sine, cosine, tangent in their normal forms, right? We can't use SOHCAHTOA, so we have to use this law. Number one. In example 1, let's go ahead and find lowercase b. Lowercase b is across from capital B. So to find lowercase b, clearly we probably want to use the law of cosines that has lowercase b at the beginning. If it has lowercase b at the beginning, it'll have capital B at the end. So we'll leave that as is. Lowercase a is across from capital A, so that's 25. Lowercase c is across from capital C, that's 29. Minus 2 times 25, 29. Cosine capital B. Alright, we can do this whole calculation in one step on our calculators. So I'll do that. Let's go to our calculator and we'll turn it on, clear the screen, make sure we're in the right mode. Degree mode is important here. So we want to go 25 squared plus 29 squared minus 2 times 25 times 29 times cosine 130. Press enter and you get that crazy number, 2,398,042. So b squared equals 2,398.042,034. Bring it out to a lot of decimals here. And then obviously we're going to take the square root of that. So the square root of that answer in your calculator, you just hit square root, so it's second square. And then you don't have to type that whole crazy thing in, you just hit second answer, which is down here at the negative, and you press enter. So your answer for lowercase b is 48.97. 48.97. And that's it. And that makes sense because remember we talked about the inequality theorem. If the biggest angle is right here, and clearly a triangle can't have more than one obtuse angle. Since that's the biggest angle, it has to be across from the biggest side. And about 49 is certainly bigger than these two. So that makes sense. Number 2. In example 2, we're going to actually find angle B. So the directions are a little bit different this time. Find the measure of angle B. Alright, so the first thing that we are going to realize pretty quickly is that we can't do that in one step. This is a two-step process. We can't immediately find angle B because we don't know little a, right? So let's find lowercase a first. Lowercase a first. If we're finding lowercase a, we want to use the version of the law of cosines that starts with lowercase a. Starts with lowercase a, ends in capital A. Memorize that, it's important. So a squared is equal to b squared, 24 squared, plus 14 squared minus 2, 24, 14 times the cosine of 91. Alright, so I'm going to show you maybe a little bit quicker of a way. You don't have to do this in two steps, you can do it in one. At the end we're gonna square root this thing. So let's just start with a square root. Let's start with a square root and do square root of 24 squared plus 14 squared minus 2 times 24 times 14 cosine 91. And we get 27.995. So that's what A is equal to. 995.14274. Again, I just typed that whole thing in. I hit the square root and then I typed this whole thing in all at once. Okay. So that is little a. That goes right here. Cool. So now we're actually ready to find angle B. If we're going to find angle B, start with lowercase b. Alright, and we just plug in the stuff we know. Lowercase b is 24. Lowercase a we just found. I'll kind of shorten this a little bit. Lowercase c is 14 minus 2 times 27.995 times 14 times the cosine of capital B. We don't know that, so we need to find it. Okay. So now we have this crazy thing here. And let's see, what I'm going to do is show you some calculator tricks for this as well. So let's clear that out. And let's see. I want to, well, let's just do it step by step here so we don't confuse anybody. 24 squared is 576. So that goes right here. Alright, 27.995. Alright, remember that was actually out to a couple different decimals, a couple more decimals. So I'm going to press second enter, and that'll bring up my previous entries. So I need to square that answer, so I'm just going to hit square. 783.728. 783.728. And then there are more decimals, but I won't write those down. 14 squared is 196 minus 2 times, let's see, I want to bring that back up. I want to bring, alright, so I press enter on that. Alright, that gives me this crazy decimal. I'll multiply that by 2 and by 14. This would be a negative answer. And oh, that's pretty cool. It's kind of like, it's pretty similar actually. Alright, so 783.864. So I'll put this right here, 783.864. Cosine capital B. We don't know B, so we need to find that. Alright, so we want to get capital B by itself. Right at the bottom, we want B by itself. So we want to take this and move it over. So do the inverse of it. The inverse of that thing as it sits there is a minus. So we'll subtract 576 minus, let's see, we want to bring 783.728. So I'll just type that in, 783.7280171. It's important to use more decimals here. And that is a negative. Alright, and that's okay. Negative 207. I'll put it in black again. Negative 207.728. Yeah, 728.017. Great. So that equals 196 minus this whole business right here. And let's take this thing over, the 196. We'll take that over as well. We could have just combined these two together first. That's totally fine. So we want to subtract 196, subtract 196. I'm taking that answer minus 196. Negative 403 is what we get now. Negative 403.728017 is equal to negative 783.864 cosine capital B. Alright, cool. Just about finished here. Again, we want capital B by itself, so we need to get rid of this multiplier. To get rid of a multiplier, you divide. So we're going to divide on both sides by negative 783.864. So I've got divided by, and again I want to use as many decimals as possible, and you can see it's up here. I'm not going to put 864, I'm going to put 8639968. That's pretty precise. 0.515. 0.515. So that's equal to cosine capital B. There are more decimals here, of course. Alright, and now if we want the angle of capital B, we're going to use our inverse trig function. To get rid of a regular cosine, you use the inverse cosine. So now we're going to go second cosine of that answer. And mercifully we're finished. 58.999 degrees. So the measure of angle B is 58.999 degrees. Cool. Kind of a long problem, but you know, all that stuff, all these decimals can be managed pretty easily with your calculator. And there's the bell, of course. Sorry about that again. That happens a lot. Let's go to example 3. So in this example, our job is to find the measure of angle C right in here. So if we want to find the measure of angle C, this is a side situation, so it's definitely going to be law of cosines. Can't use regular sine, cosine, tangent because it's not a right triangle, so I need to use the version of the law of cosines that has a C at the beginning, lowercase c, capital C. The other two letters are obvious, A and B. Alright, so we have, let's see, lowercase c, that's 29 degrees. Excuse me, 29 squared. 13 squared. 21 squared. Minus 2 times 13 times 21 cosine capital C. Alright, that's what I'm looking for right there. Okay, so go through this again for you. So we want 29 squared. This is like the previous problem, only a little bit easier because the numbers are all integers. This is 841. 13, that's 169,441 minus 2, oops, the bell again, apologies. 2 times 13 times 21, 546. Cosine C. Alright, so this time let's add these two together first. So 169 plus 441. 610. Alright, so we've got 841 equals 610 minus 546 cosine C. Again, we're going to want to get rid of the 610 by subtraction. Subtraction right here. So we go 841 minus 610. It's 231. Could have did that in my head, sorry. equals negative 546 cosine capital C. These are multiplied together, so we're going to want to undo the multiplication by division. The inverse is division. So it's 231 divided by a negative 546. And we get ourselves a negative 0.423. Negative 0.423 is equal to the cosine of capital C. Okay. Let's see here. We have to do the inverse of cosine, of that decimal, and there are many more places to that decimal, but I'll let my calculator do that work. So I go inverse cosine of that decimal. That is my answer, and I get my degree, 115.029. So the measure of angle C is 115.029. Alright, so that's a little bit easier. I'll show you a quicker way to do that in your calculator right now. So we can do this all in one step in our calculators if you want to. So what you do is at the end you have to realize that we want to hit inverse cosine. So let's hit that first. So you go inverse cosine, open a parentheses, 29 squared minus 13 squared minus 21 squared. We're kind of just doing everything backwards. So we put a parenthesis around that little section there, and we want to divide that by parentheses negative 2 times 13 times 21. Close, close. Should get the same answer. Yeah. So that was a little confusing. Rewind it, try it again. It's the quickest way to do a problem like that in one set of keystrokes. Number 4. Alright, this problem involves a little bit more work, right? It says kind of vaguely solve the triangle. What that means is you need to find everything that's missing. So we defined all the angles. Alright, this is side, 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 so it's law of cosines. Let's simply start with A, just randomly. You don't have to start here, but alright, so you find A, capital A. So we know little a is 28. Alright, so that has to go right here. Lowercase b and c, we can mix those up because of the commutativity of addition. You can mix these up too, it doesn't really matter. I'll keep them nice and uniform though. And cosine A is what we're looking for, capital A. So again, let's get some practice with that. Those calculator keystrokes here, we're going to enter in all at once. Inverse cosine, open a parenthesis, 28 squared minus 30 squared minus 36 squared, close that parenthesis, divided by open parenthesis, negative 2 times 30 times 36. Close, close. You probably don't even have to close those last two. 49.179. Alright, so that's one of our answers. That is 49.179. I'm going to put that right in here. Alright, next up, angle C. Just randomly, if we want to find angle C, start with little c, a squared, b squared minus 2ab cosine capital C. Make sure you make a nice distinction between lowercase c and capital C, lowercase a and capital A. Alright, so we plug in, make sure that the 36 goes here, A and B can be switched around, but I'll keep it nice and uniform. And capital C is what we're looking for. So again, let's go to our calculators, see if we can hit this all at once. Open a parenthesis, 36 squared minus 28 squared minus 900 divided by open parentheses negative 2 times 28 times 30. 76.647. 76.647. Highlight. That goes right here, 76.647. And finally, letter B. At this point, you certainly you might be tempted to use the triangle sum theorem to get this last one, and you can. But you know, what happens if these two are wrong? Then you have another one that's wrong. So, what I like to do is find my angles independently of each other, and then at the end, see if they're all correct. See if they add up to 180. So let's find them independently of each other. So lowercase b is given, that is 30. Little a is 28. Little c is 36. Capital B is what we're looking for. So let's put that into our calculators. Again, if we're doing it all at once here, good practice. Inverse cosine, open a parenthesis, 30 squared minus 28 squared minus 36 squared, close parentheses, divided by open parentheses, negative 2 times 28 times 36, close. 54.175. 54.175. All right, so the moment of truth here, we need to make sure that these three add up to 180. So 54.175. So I'll go to my calculator here, and I'll just add those together. So I got 54.175 plus 76.647 plus 49.179. They should add up to 180. Let's see if they do. Yep. The reason it's not exact is because these are rounded numbers. These are approximated to the 1,000th degree, but that's pretty close enough for me. That means that I'm right. All right, so that was the law of cosines. In the next video, we'll tackle the law of sines and really try to hammer home when to use each law.